Hello, welcome to your first background video for whole lot of slippage. So first of all, we need to talk about torque. So what is torque? Well, torque is the force that makes objects spin. So here we have a wheel. To make this wheel spin, what do we need to do? Well, if I apply a force at the center of the wheel in this direction, that's not going to make the wheel spin. That's just going to push the wheel. So what I need to do is I need to apply a force that's tangential to the wheel. And that is also perpendicular to this line here, which is drawn from the axis of rotation to the edge of the wheel, which I'm going to call the lever arm that has a length of r. This is the force that's tangential. So how do we quantify torque? Torque, or tau, is equal to the length of the lever arm, or r, times the force. So let's say we have the lever arm being 1 meter long, and the force is 2 newtons. That means the torque felt at this point right here is equal to 2 Newton meters. And look at these units. These units are the same as work, which is equal to the force times the distance. And this is important. Why? Because this means the torque is the same anywhere on an object, just like how work is conserved in a system. So let's try to find the force over here at this point. The lever arm is shorter here. This is, say, 0.5 meters. So we already know the torque, which is always constant throughout this object. So 2 Newton meters. And then, this is equal to the radius, which is 0.5 meters times an unknown force. So to find that force, we can divide 2 Newton meters divided by 0.5 meters, and then we will find the torque is 4 newtons. And that makes sense. This point will travel less than a point on the outside of the wheel. And so when the distance is traveled is smaller, the force you felt is greater. And that's consistent with our formula over here. So the fact that torque is the same anywhere on an object is quite important in the task you will be solving. So on a car tire, for example, it is connected to an axle like this. These two wheels are connected together and they will rotate together. So the force felt on this wheel is the same on this wheel, and the torque felt on this wheel is the same on this wheel as well. And what some cars will do when they experience low traction, let's say there's like an icy surface or an uneven road, they will distribute their torque evenly from the engine between the front and the back wheels. So let's say a car produces 200 Newton meters of torque. That means each wheel, or each half of the car, will be getting 100 Newton meters of torque. And that torque will be the same here, 100 Newton meters, 100 on this wheel, 100 on this wheel, and 100 on this wheel. And hey, guess what? We know the torque here now. We can find the radius of the wheel. That means we can find the force felt on each wheel. If the torque is going this way, we can find the force that is tangential to the wheel going this way with the formula over here. Next, let's talk about static friction. So static friction is the force that holds stationary objects in place. Let's say you have an object here and you're trying to pull it in this direction. When this object is stationary and it's not moving, while you are still applying the force, there's going to be an opposite force in this direction. That's going to be exactly opposite and equal to this applied force we're going to call Fa. This is F static friction. And this static friction force depends on a few things. The force of friction is equal to the normal force times the coefficient of static friction. Well, the coefficient of friction. So first of all, what is the normal force? The normal force is the force felt between two surfaces. So for example, if I push my hands together like this, the normal force is the force that's like in between my two hands. The harder I press, the more normal force my hands will feel. And also, the harder I press, the harder it is to slide my hands against each other. That's because the friction is increasing. When the normal force increases and the coefficient of friction is constant, friction increases. So how do we find the normal force for an object just sitting on the ground? Well, when the ground is perfectly flat, the normal force is going to be the equal and opposite to the gravitational force. And this is going to be equal to the mass times the gravitational field strength of Earth, which is 9.81 newtons per kilogram. And this formula here is a simplified formula. Here's the full formula. F, the force of max static friction is equal to the normal force times the coefficient of max static friction. So why do I have this maximum thing here? Well, the force of static friction is always going to be equal and opposite to the applied force. It will always match it until the applied force exceeds the maximum static friction allowed. And when that happens, the object will start to move. Here, I have an example for you. So we have a wheel here. So normally what happens when you roll a wheel on the ground, the wheel rolls like this. And if you look closely, the point of contact between the wheel and the ground is stationary, meaning the wheel doesn't move relative to the ground. This is when the static friction force is greater than the applied force on the wheel. But if the applied force on the wheel is greater than this maximum static friction, like when a race car starts accelerating really fast at the beginning of a race, the wheel might begin to roll like this. The wheel is going to spin, but it's not going to move relative to the ground. And if you can see here, the wheel is slipping on the ground, and that's going to create some tire marks on the ground, just due to abrasion, just like how you rubbing your eraser around on a piece of paper is going to leave little marks of eraser around. And also another thing to keep in mind when you're dealing with a normal force. The normal force can be distributed over multiple points of contact. So think about, like, if you have a pebble in your shoe, would you rather stand on both feet or just a single foot where you have your pebble? It obviously hurts less when you stand on both feet. Why? Because your weight is distributed over 2 points. So the normal force, the force felt between two surfaces, your foot and the pebble, is reduced. It's halved if you stand on both feet. And next, we'll go over the biology portion of the background information. So watch the next video. Bye.